Good day, viewers. Welcome to Master Builders Online Academy, the only online academy where you can learn all the tips that you need to gain mastery in any calculation course at all. Now, you are welcome, you are welcome, you are welcome, you are welcome. Happy you are here. Now, let me tell you this. Do not skip any part of this video. This will do you a really good because every aspect of this lesson is bundled with principle, is principle based. So if you skip any part of this video, you may miss vital information that will have helped you gain mastery over this aspect of this class. And also, anytime you are set to watch and to learn new concepts from this platform, do not entertain any form of distraction. This is for your own good. And finally, if there be any part of this video that you do not understand when you watch it for the very first time, guys, you have the singular opportunity to replay the video over and over and over and over again until it sinks into your mental capacity. And not until then, do not stop watching this video. And if after replaying the video over and over again, you still have questions to ask or areas you are not fully clear with, guys, don't hesitate. Slide down to the comment section and make your questions known to us. We will answer your questions and you will benefit from it maximally. Now, lest I forget, this lesson, we shall be looking at logarithms. Yes, we shall be looking at logarithms. Of course, usually, you know that logarithm is divided into two classes. One is logarithm with the use of table. The other is logarithm without the use of table. And in this lesson, we shall be majoring on logarithm without the use of table. Hence, the theorems of logarithms. Now, on a note, we know that logarithms is normally to base 10. If, take for instance, I have this guy, this is log to base 10. Why? Anytime you are given a log of a number or the logarithm of a number, without a base, it shows that that logarithm is to base 10. So the general notation for a logarithm is actually given as log n over b. This is the logarithm of the number. This guy is the base. Hope you are getting values. Please pay attention here. In this lesson, we shall be taking this guy here as number and this guy as the base. So this is log n base b. Log n base b. This is the least that the logarithm of a number can be. Now, we have logarithm without the use of table, like we are explaining now, or like we are dealing with, and logarithm with table, the use of table. Now, every logarithm you are dealing with the help of table are logarithms to base 10, which can either be represented as log 50 base 10 or just log 50. So log 50 base 10 is the same thing as log 50. When the base is not given, such log is to base 10. So this type of logarithm is called the natural logarithm. But under the theory of logarithms, a logarithm can have different bases that are actually different from base 10. So the log of a number can be to any base, and anytime you are considering the log of a number to any base different from base 10, the theories of logarithm comes in. So generally, we can have a logarithm of a number to base 5. to base 8, to base 20, to base 50, to base 100, to any base at all. And that is the reasons why we are here to look at this aspect. But mind you, you will not be able to solve the long readings of number to any base effectively without knowing the principles and the laws that works. So when you are successful in dealing or handling problems in indices, guys, it will equally be easy for you to solve problems effectively in long reading. The same principles or the same laws that we used in indices are the same laws that are applicable in long reading. So if you are here, you have not watched our content on indices, please kindly check our playlist where you will see a session that will demystify problems effectively on indices. I know your mind is blown up already. Now let's go. When we look at this is log N, this to base B. So when you have this, like I explained, the list of any log readings you will ever have under the theories of log reading, the least value can either be log 5 base 2 or you have a simple number. So by the time I have 5 log 5 base 50, this is very complex already. So this is the list. By the time I have more than this, the number and the base, or I have more than just a simple term, if this cannot be reduced to a simple term, then the laws of long readings comes in. So majorly the laws of long reading comes in when you try to combine two or more log of a number to a base together. So anytime you try to add, subtract, or do any mathematical operations with multiple log of a number to either the same base or different base, the laws of long reading comes in. So very quickly, we shall be examining the laws of long reading. We shall be looking at the laws of long readings. And very shortly, what is the first law of long reading? Now we have laws of logarithms. Now the law number one is the addition law. Addition law. So anytime two log readings are added, I have log of A to base x plus log of B to base x. This is equivalent. So you find out that in this case now, we are adding two log together. And anytime this happens, what you look out for, listen carefully, pay attention to this part. Yes, because I want to unveil a secret that will blow up your mind. Now, anytime you are given the addition of multiple log of number to the same base or to different base, look at the three things that you watch out for. There are basically three things that you watch out for. Number one is the coefficient of the log. What do I mean? The coefficient of the log. You find out that here now, the coefficient of this log is 1. The coefficient of this other log is 1. You must ensure that the coefficient of the log is 1 for this log to be valid. Number two that you watch out for is that they must have equal base. So this is base x, and this other guy is equally to base x. Then finally, you must find out what is connecting the two log or the numbers of log, if there are more than 2. But for this case, we have 2. What is connecting the second log to the first? So these are the 3. Number 1 is ability to identify the coefficient of the log. They must have equal coefficient, which is normally accepted as 1. So the coefficient of the two log readings that is to be added together must be 1. Number two is that they must have common base. Then number three is that you must be able to identify the sign that connects the two or more log of the number that you have given. Are you there? Now, if this is taken so, I have found out that the coefficient is the same. I will pick one of the a. Then what happens? I will now multiply the logarithms or the numbers, which means a multiplied by b. And a times b is ab. This is addition law. Then we have law number two, which is the subtraction law. Now, in this law, we have log a base x minus log b base x is equal to. Now, the same thing that is applicable to addition law is applicable to subtraction law. What are the things you watch out for? One is the coefficient of the logarithm. It must be 1. Two is that they must have common base before you can apply this theory. The three is that you must check the sign that connects them, addition or subtraction. Just like in indices, that when you have two bases multiplies each other and the bases are equal, pick one of the bases, add up the power. Is that correct? So in this case now, anytime you have addition, it comes to multiplication. Now that we have subtraction, it will turn to division. So what you have in indices is what is applicable to all of these guys that we have here. So in this case, we will pick one of the base, then divide the first log number by the second log number. Then this becomes a divided by b. Of course, naturally you know that a divided by b is the same thing as a divided by b. Is that correct? That's it. If this is understood, then we are good to go. So understand that log a divided by a divided by b is the same thing as this guy. So whether you put it this way or you put it this way, you are very, very correct. Now, what is law number 3? Law number 3 is the power law. Power law. In this law, we have that the log a raised to the power of n base b. So you find out that the logarithm has a power. So anytime the logarithm has a power, all you simply do is to remove that power and use it to multiply the log. Or in other words, it will now serve as the coefficient of the log. Then we have this guy to be n log a base x. This is what this law is all about. This guy is law number 3. Then law number 4. It's the reciprocal law. Now, this reciprocal law is applicable when you have a log of a base x. What you do in reciprocal law is just to have 1 over, which agrees to the 4th law of indices, right? So this is same thing as 1 all over. So anytime you introduce a reciprocal, all you need to do is to swap the position of the number and the base. So the base becomes the number, while the number becomes the base. Hope you have gotten this principle. Therefore, I will then have this as log x base a. I just swap the position of the number by that of the base. Law number 5. Law 5. Power of the base law. You see, unlike law number 3, it was the number that had a power. But in this law, the base had the power. What do we mean? We have that the law of a x raised to the power of n. So you find out that in this law, or in this theory, what is applicable here is that the base is now raised to the power of a number. And how do you remove this power here? To remove the power, all you simply need to do is to take it as a reciprocal and then becomes the power of the number. So if I am removing this power from here, automatically this guy will have become a raised to the power of 1 over n. Then is x. So anytime you are transferring the power of the base to the number, you take it as 1 over, which is reciprocal of the original power of the base. So you have it this way. Or now make use of law number 3. Then you can have this by extension as 1 over n log a base x. So you can either convert to this form or this form, whichever case is applicable. Alright? Now, this is all about this law. So in this law, it is the base that carries a power. Hope your mind is blown up already. Please keep following as we begin to unveil the secret of these theorems one after the other. Now, when we look at law number 6, law 6, this is logarithm of 1. Logarithm of 1. Now, listen carefully. The log of 1 to any base at all is 0. So this is how the theorem is. Log 1 to base x is 0. What this means is if I have log 1 base 10 is 0. I have log 1 base 100 is 0. I have log 1 base 500 is 0. So the log of 1 to any base at all is 0. Now, let's look at law number 7. Law 7. Law 7 is logarithm to its own base log. You see, you can have the log equals to the base. So when the log is equal to the base, there is a standard value for it. Yes, there is a standard value anytime the log is equal to the base. So if, for instance, I have log take for instance, I have log x base x. This is equal to 1. Or log a base a is equal to 1. So the log of the same base is 1. So anytime the log of a number equals its base, the outcome is 1. Then finally, law number 7, 8, log 8, is what we call the change of base law. Change of base law. This change of base law is very, very useful anytime you are given addition or subtraction of different logs where the base are not equal. So when 2 or multiple log are added or subtracted, and at the end you find out that they are not having equal base, this law is suitable for such problems. So if I have this, then all I need to do, if for instance I have log a base x. So using this law, all you need to do is to introduce a base of your choice. And you know that this base we introduce is based on other base that you are given in the question. So I can decide to change the base x to any other, provided that it suits or aligns with the question that I have. So what we do here is to have log of a over log of x. So introduce your new base. So let's assume the new base is a, small letter a, small letter a. This is all we have. So anytime you want to change base, you can have the log of the number over the log of the base. Then bring in a new base. Now, okay, let me give you a scenario to clarify this aspect when this guy should be used. Take for instance, you have log 81 over 3, then plus log 64 over 2. So you find out here now, according to the logs earlier stated, I mentioned that for this log 1 to work for this guy, that they must have equal coefficient, agreed already, and equal base. But now when you look at it, you find out that the base here are not equal. So since the bases are not equal, I will find something else to do, a step to take, that will have the base here to be equal. What must I do to make the base here equal? Now, the question is, you will decide either to leave your base in base 3 so that you change this guy to base 3, or decide if to leave your base in base 2 so that you change this guy to base 3. So if I want to change this guy, everything here to base 3, for instance, what will I do? All I simply need to do is to have this as log 81 base 3 plus log 64 base 3 all over log 2 base 3. This is when the change of log is actually useful. Okay, so anytime you want to change base, you change it based on what you are given. Another person can say, no, let me change the base to 2. You see now, at the end of applying this law, you find out that all the base are now to base 3. Another person can say, no, I want to change the base to base 2. The same thing is applicable. All I need to do, I will now work on this guy. Then I will have log 81 base 2 over log 3 base 2. Log 81 to the new base I'm introducing, then log 3 to the new base I'm introducing. So instead of this guy to be a number and this guy being a base, both of them will now be the number to a new base entirely. Then plus log 64 base 2. So you find out that everything here now is in base 2. That's if you solve this guy and solve this guy, you are going to have the same result. That's why there is no problem in mathematics that is solved only in one way. There are so many ways to kill a rat without actually sharing its blood. So same way, there is so many ways to solve mathematical problems and still arrive at the same answer. Now, there are other laws of long readings that can also be of help to you. There are basically two other laws of long readings that you need. And this aspect or these laws is traceable to what equations or long readings involving equations. So I will quickly give us the two laws, then we will start solving problems using these laws. I know somebody is already anticipating for that new next class where we shall be solving problems using these laws of long readings. Now, okay, now we have other laws. And like I explained earlier, these other laws are applicable to long readings involving equations. What do I mean? If, for instance, I have log a base x is equal to n, you find out that equation always comes in anytime you have equal to in between numbers. So this is the first law here under equation. So anytime you have this, understand that long reading can also be converted to index notation. You know, when we're dealing with indices, we have what we call index notation. And we start that indices is actually what the simplification of multiple or complex index notation. That when two or more index notation are combined, then indices comes in, right? So in the same vein, log of a number to a base equal to anything can also be expressed in index notation. How do we do this, guys? Just pay attention to this. Please pay attention to this guy. Okay? Now, look at it. To convert this guy to index notation, all you need to do is to take the base, equate the base to the number. Equate the base to the number. Then what you have at the right hand side here now becomes the power of the base. I hope I have made myself clear. Equate the base to the number, after which what you have at the right hand side here without log will now become the power of the base. Therefore, this becomes s raised to the power of n. This one, we can call this one equation 1 under logarithms involving equations. Then the second but not the least law is log a base x is equal to log b base x. This is the second law. So you find out that two log are separated with equal to sign. In other words, you have the left hand side, you have the right hand side. Now that these two guys are separated with equal to sign, or like this case, these two are separated with what? Addition sign. These two are separated with what? Subtraction sign. But these two guys are separated with what? Equal to. So anytime the log of a number to a base is equal to another log of a number to a base, all you need to watch out for one is to check their coefficient. Do they have equal coefficient? If yes, one credit. Because there are three things you must watch out for. Number one is what is connecting them. Number two is if their coefficients are the same. Then number three is if they have equal base. So like we see here, these two guys have equal base. So anytime they have equal base, the log here can take care of the log here. Therefore, we equate the numbers. This is equation 2. This guy is what you used to do when you were dealing with indices. Or for those who have done indices at all, or you have not looked at our content on indices, you see that in indices, if I have x raised to the power of a is equal to x raised to the power of b, we said that anytime the bases are equal, you cancel the base and equate the power. Is that correct? That's it. That's exactly what we just did here. The same way in indices, we have x raised to the power of a is equal to y raised to the power of a. We find out that in this case, the power are equal. Therefore, we cancel the power and equate the base. This is indices. That's why I stated earlier that if you are good with indices, you only need simple principles to gain mastery, solving problems effectively on logarithms. Practically, theorems of logarithms. So very quickly, guys, we shall be solving problems using these principles. But get it clear, do not move to the next video if you have not gained mastery over these principles. Why? Because you will never be able to solve problems effectively on logarithms if you do not know the principles that are applicable. So please, I beg you to ensure that you acquaint yourselves with the principles, the laws, and the theory first before you dive into solving problems using these laws. And I bet you guys, if you are able to acquaint yourselves with these principles, guys, you are already 70% good in solving problems on a logarithm. Already good in solving problems on a logarithm. So guys, don't forget, if you are yet to subscribe to this YouTube channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting videos. Guys, do not be selfish. Share these videos to your friends so that it can equally be helpful to them, whether in the same university with you or in other universities. Share, and let this video go viral so as it can benefit others the same way it benefited. So guys, I will see you guys in the next class. Lest I forget, don't forget, just check the description below where you will find the link to the next video. We love you. Thank you for watching. See you guys in the next class.